Okay folks, let's have a look at adding and subtracting fractions. Again, this is non-calculator. I'm going to try and keep it as brief as I can, but make sure this gets copied down into your notes book. So in general, we want to multiply both fractions to try and get a common denominator, and then we want to add and subtract the numerators only. Let's see how that works with three examples. So we've got 2/3 and 4/5 here. The denominators are 3 and 5. I want those to be the same denominator. So the smallest number that 3 and 5 would both go up into is 15. And if you can't think of a number that 3 and 5 would go into, you just think, what's 3 times 5? To make that happen, I would need to multiply this first one by 5 and this second one by 3. I need to do the same to the top and the bottom, so that's going to give me 10 over 15 and 12 over 15. Then look at the fact that it's an addition. 10 plus 12 is 22. We just add the numerators over 15. Not 22 over 30, and then we can take out 1 and 7/15 because 15 goes into 22 remainder once, one time remainder 7. Second one, we've got 12 and 8, and the reason this one is here is because there will be an instinct among some people to go times this one by 8 times this one by 12, but it's not always the case that you multiply them by each other's denominator. What you want is to get the number on the bottom to be the same, and in this case it's easier to times this by 2 and this by 3 to make it 24. The reason we might want to do this is it means the calculations will be more straightforward. Instead of having to do 12 times 8, we're just having to do 12 times 2. We'll get 14 and 3, and then it's subtract, so make sure that you see that. A lot of people will instinctively want to add their fractions together. 11 over 24. Third example, 15 over 4 take 3 over 5. Again, I want a number that they will both go into, so they will both go into 20, which is 4 times 5, so I'm timesing this one by 5 and this one by 4. That'll give me 75 take away 12, which would be 63 over 20. And again, make sure you go to a common, to a mixed number. 20 goes into 60 3 times, remainder 3. Okay, so that's the basis, and I just want to point out one extra little shortcut that you can consider using with mixed numbers. So we've got here 3.5 plus 13 and a sixth. And your instinct might be to say, well, change this to a mixed number, change this to a mixed number, which would be 99 over 6, times this one up by 3, add them together, simplify it down. There's an easier way, okay? And the easier way is this. We are doing an addition here, and we've got 2 and 6 as our denominators. So I'm just going to times the fractions. I'm going to times this one by 3, so it's 3 over 6. And I'm not changing the middle the big number. So we're just making that fraction from a half into 3/6 because that's the same thing. So I've got 3 and 3/6 and 13 and 1/6. And what I can do is I can put the 3 and the 13 together to get 16. I can put the 3/6 and the 1/6 together to get 4/6. And then I can simplify down 4/6 to be 2/3. So you do not need, in adding and subtracting, you do not need to change to improper fractions first. You can do if you find it easier to do so, but in this case I would say it's a lot easier to just add the fractions and the big numbers separately. So let's see how we do that on this second example. We've got 22 and 4/5, so again leave 22 and leave 7, and we're going to make this number 15 because that's what 5 and 3 both go into, and it's a subtraction. That means I'm timesing this one by 3 and this one by 5. So that'll give me 12 over 15 and 10 over 15. Then I just need to do, and it's a subtraction, so be careful here, 22 take away 7, that's 15 for the big number. 12 take away 10 for the numerator, still over 15. 15 and 2/15, and that can't be simplified. And you can imagine how much quicker that is than working these out as improper fractions, which would be 114 over 5 take away 23 over 3. And look how much much less maths we had to do. Let's try one more, and this one's got an extra thing we've got to bear in mind. This is 19 and a sixth take away 2 3/4. So let's do the same thing. what does 6 and 4 both go into? Well, we could have 24 if we did 6 times 4. We could also have 12 because that's 2 times 6 and 3 times 4. So let's go with 12 as it's smaller. So I want to times this one by 3 to make it 12 and this one by 2. 19 and 2/12 take away 2 and 9/12. And this is where you've got to be careful with the subtraction, okay? So 19 take away 2, that's 17, that's not an issue. But we want to then do 2 take away 9. So how do we do that? Well, it's not 9 take away 2, it's not 7, it's minus 7. So we actually have to do 17 take away 7/12. Now there's lots of ways of thinking about this question. One way you could think about it is split up 17 into 1 and 16, and then think, well, what would 1 take away 7/12 be? So a whole would be 12/12. So what would be left over if we took away 7/12 and 12/12? We would have 5/12. Another way of thinking about it would be going straight from here to here by just saying, well, I know it's got to be less than 17 now, and I know I'm taking away 7/12, so there must be 5 of them left over. Another option would be to convert things to improper fractions at the start and just work through it sort of longhand. Just bear in mind those are all options and they all work. It kind of depends how much time you want to spend on something, but if you can remember this shortcut of calculating with the big numbers and the fractions separately, it saves a lot of time. Okay, cheers.